So you should have at this point done all of these things. Hopefully the Tidyverse was able to be installed. And you're happy there. There's actually one thing I want to show just as like one more fun thing. So there's been recently, I don't know how many of you guys are on Twitter. There's recently been just a blow up of R and Stata debate and controversy on Twitter. I've just pulled up just a few because they're fascinating. So this guy says the whole debate's stupid. I think this is fascinating. Jeremy Fries is here. I don't know who that is, but do we know?
He's a colleague of R.
Okay, so we know who he is. So he says I want a contest of R versus Stata, and I think Stata would dominate. And the person, sort of the protagonist in the world of R, is Hadley Wickham. And he responds, bring it. And this is just fascinating to me. I think there is no doubt that R would win, but you'll be maybe in a slightly better position to decide. And then everyone wants to like make it a stadium event and everything, which is great. And then this is the last one that's really good. I won't dive through all of these things, but it's sort of the perceptions of people that use software on other people's software. And so there's lots of little funny things. Like Stata people think they're like sophisticated business folk. R people think they're like doing amazing things. SPSS is getting shade for just being homework for whoever's doing it. So in your free time, you can engage more with that. But I think the subtleties of this humor is fascinating. Any comments on that? Anything particularly fun before we move forward? All right, let's open our studio.
I have a question.
Yeah.
Why do people use R instead of Python?
I will be in a better place to answer that after we talk today. The Python is sort of this all-purpose tool that's used for like software development and the back ends of crazy things. R is, and it makes you, I think like a software developer or like a programmer in a way. R is very much, and Hadley's tools in particular, are very much geared towards data analysis. And so, I don't know, do you have a better answer to that? Scott's more of an expert in Python than I'll ever be.
Yes, I'm a Python person who then picked up R. I do most of my work in Python. Python is a general purpose programming language, like I said, whereas R is really oriented towards data analysis and statistical computing. People have expanded R in different ways, but you're never going to build web applications or build websites or whatever in R. Both are the sort of dominant languages within data science. If you get a data scientist job, you're expected to know R and probably Python. The difference I think is that R has a lot more statistical capacity in the base R package, whereas Python, you're going to install libraries to do anything useful with data analysis. And the libraries are very good, but you have to install them. I think some of the split right now that we see is where is industry money going? So the big industry people like Google, Facebook, so forth, they do a lot of research in Python. And they publish all of their machine learning libraries and their neural network libraries and everything else first in Python. And then the R community is picking those up and either doing sort of R adaptations of them or just actually accessing Python libraries from R. There's a number of things that you'll do in, say, text analysis where you're actually using Python libraries, but you're using it through an R interface. I think either one, like I said, I work in both. I think that they're both great languages. If your main thing is data analysis and statistical work, and you don't need servers and you don't need really advanced machine learning and neural networks, just work in R. I think a lot of things feel easier. But if you need some of these other features or you need like cutting edge things coming out of industry world, Python often is a bit better choice.
I think for the modal person in this room, you want to learn R and not Python. Like if you want to be a data scientist at Facebook, maybe you want to learn Python. If you want to like do your own academic data analysis, I think R is probably better. There's also probably, I don't know, in this one, R people are jealous of Python, and Python people think R is this like weird vehicle that they don't know how to operate, is maybe the wisdom from that. Okay, so you should be here. And I really want you to tell me if you're not here, and then we can figure out, Scott can walk around and help you out. And so I'm going to introduce you to this, but first we're going to sort of make a project where we can organize everything. So go to your desktop and just create a folder that we're going to sort of work in for this class. I'm going to call it SS382. You're welcome to call it whatever you would like. And so that's going to be our home base or our working directory. You must be familiar with this from Stata in some ways.
Are we gonna tell R?
Yeah, we're going to let R know, which is going to be cool. So now once you're back into R, you should have an empty folder on your desktop or wherever you want to work. And R has this notion of projects, which is really nice. So I'm going to click New Project. And then I just made the folder. So I'm going to click Existing Directory. And I'm going to browse to where that is. And now I'm basically saying create a project. So I'm telling R that my focus is going to be within this folder. I'm going to create the project, and then it should put me there. That good? We're there. And so you'll notice, like, now if you went back to the folder, it's created this R project file. And so you don't need to do this because it might, but the way I work is like I will open up, I don't open up R, I open up these project files, which opens up RStudio within that folder. And so instead of like opening up a blank R session and setting my directory, I just always open that up. And that becomes really convenient when you're working on multiple projects.
So previously I had a whole bunch of stuff in my environment, and now that I've sent it to this empty folder, now my environment is empty.
And that's really good, right?
Okay. Well, I mean,
I think it's good.
Right.
It's like,
it's good to keep straight.
Yes.
What stuff is where, which is one of the key things that we need to do.
and so now if you work for a while in here and then you open this up again, all of that stuff will be in your environment here. But if you switch to somewhere else, it'll be you now have multiple worlds of R as opposed to just one, which is nice. So then I'll just sort of acclimate you to, do your panes look different than mine? It's in a different order. So we're already coming across my preferences. If you go to RStudio Preferences, I suggest that you make mine look like mine, but that's sort of, by definition, I like this. I have the source in the top left and the console in the top right. You're welcome to, I wouldn't worry about these checkboxes. You can just decide where you want things. And for this purpose, so I'm going to make this clean like this. And so now my console's on my right, and this is where code gets like executed. So if I type 2 + 2 here, it's going to tell me what that is. And my code's being executed there. Most people don't type into the console. Stata has analogs to this that you're maybe familiar. This is like a do file over on the left-hand side, where this is where I'm going to script my code. And maybe I'm going to, like, the most simple command I can type is 5 + 5. And the way I execute this is if you're on a Mac, if you hit Command Enter, the line you're on will execute. If you're on Windows, I think it's Control Enter. The line you're on will execute. And so now your workflow will be you'll type here and you'll execute line by line. If I highlight and then hit Command Enter or Control Enter, it'll execute everything that's been highlighted, as an example. So that's sort of the workflow. I'll write here and then I'll just Command Enter it over there. I can make a comment. So if, as we're going along, you want to take notes, the hashtag specifies that I'm making a comment. And so if I run this comment, nothing happens because it's told that it's computer language, or that's human language as opposed to computer language. I'm going to save this. And you could call it anything you want. I called it my script, and so it's become this .r file down there. And then also, if you were to go into like on your desktop, you've created it there because you're looking into it. The main difference between R and Stata, I think, is that Stata, you always have like a data set that you're working with. And that's the thing in the background. And every command you write executes on this data set. R, on the other hand, you just have objects that you create, and then you can operate on any of those objects. An object could be a data set, it could be something else. So like, as an example, let's set, can we see, I guess zooming might be helpful. So I can set x equal to 2. And now in my environment, I have an object called x that holds the value 2. I can set y equal to 5. If I execute that line of code, now you can see in my environment, I have an object y that's 5. R also comes with these like toy data frames. So empty cars is just a random data frame that comes with R and it's in the background. If I set cars to be equal to that data frame, now I actually have a data set in the background. I have 3 objects now, 2 of which are just values, and 1's a data set. This data set has 32 rows and 11 columns. I can also make a data frame. And now I have 2 data frames in the background. I have df, which I just created, has 1 value. And then I have cars, which I duplicated from R's world. And so I think this is the biggest difference, is I can work with anything, and with that comes power, because I can operate on multiple data sets at a time and do all sorts of things, but also with that comes a little bit confusion, and you need to make sure you're telling R like what you're working with at all times. It doesn't just assume when you say like browse that you'll look at the data set that's in the background. R's analog to browse quickly is view. So if I do view cars, it pulls up this window that allows me to look into what cars looks like. But notice, this is sort of the simplest example of this, I think. In Stata, you would just type browse.
Does it matter whether it's capital V or lowercase v?
It is capital sensitive. So I do not think, let's try it for demonstration purposes. So it doesn't, it's capital sensitive. It doesn't know what the function lowercase view is. Yeah.
Could you say again the difference between the data frame and the data set?
Same thing.
So why did you have to say cars equals empty cars? Why couldn't you just pull empty cars?
So, okay, I wanted to, you can just use empty cars. This sort of gets, it's the same thing. Empty cars is not in my environment. It's sort of in R's environment. And so I wanted to pull it into my environment. Like I wanted it to show up here to demonstrate to you that it was a data frame. I could have equivalently done this. I just thought it would be slightly confusing. But it has this it has stuff in the background that if you call it, it will give it to you. But this is the stuff I've created.
It's the Department of Tautology.
Yeah,
empty
exactly.
cars equals empty cars.
Exactly, it gets confusing, right? Similarly, this view function, like R knows what the view function is, but it doesn't tell you it's here. It's just this whole world of stuff that R knows about. It's all of the functions that are living. I could write a function and then it would show up down here. So this is all the stuff I've created.
And where exactly did the cars data set come from? Was that something we downloaded already?
It comes pre-installed with R. So they give you some toy data sets, and then when people are showing like how their code works, they'll often use the empty cars data set, because they don't have to like then give you their data set to illustrate it. They can just be like, we all have access to this really. So there's a few like really popular ones. There's also this, I think there's an iris data set, which has something about flowers.
Stata has a cars data set.
So you have something.
We've never used it.
Okay. It sort of exists.
Yeah.
Something on assignment, this is something debated in the small R pedagogical community, is that if you write R code and then you submit it to someone that considers themselves sophisticated in R and you type this, like x equals 10, they will tell you you're bad and you don't know what you're doing, because the correct way is this assignment operator. And it's literally like a less than sign followed by a dash, but it creates this arrow that looks as if 11 is being put into the X world. There are some very small subtleties between those two symbols. They're essentially the same thing. For today, I'll try to just use the equal sign, because I don't think adding to your cognitive load the difference between this like new symbol is worth it. But if you continue to program in R and if you submit it to someone that's you're afraid of them judging your code, I would suggest using this.
But the LM and the GM commands, they're all about assignment into some name.
Yep.
You'll see that assignment command all the time.
Yep. The second one. This one. And I think when you do that, you could just throw equals in there.
Really?
I think.
Yeah, you could throw equals. Part of the reason that they do distinction is whereas in languages like Python you only have a single assignment, in R you can assign a value to the left or to the right. So you could actually
Don't
take a
ever do
value
this.
and assign it to the right to a variable name. You don't see that all that often.
Never
in
do
part
that.
Because the tidyverse approach
Because
that
Ben is
Ben-
not. They think Ben is not number one. Is that what you're saying? No, operation.
It makes code really confusing to read. You always want to see what you're the name and then what is getting it, but you can assign in either direction. It's a terrible.
That's part of why they came up with that syntax construction though, was because the people who wrote R wanted this capacity to assign in either way. But the tidyverse approach, which most people have adopted as the best way to do data analysis in R, that's what Ben is teaching today. They write code in such a way that you shouldn't ever need to use right assignment, which means that you only ever think about assignment in that sort of left assignment, just a pure equals way. But it's a sort of a syntactic remnant of a language feature that the creators of R wanted.
Everyone happy so far? Any other questions I can answer before I continue to go? There's the summary of that. Yeah.
Just for note-taking purposes, how do you add a comment that spans multiple lines?
There is a preference in code, continue comment when inserting new line, where if you are commenting and you hit enter, it'll continue. I don't have that on, but
And then you
can.
stop it with another hash.
there are ways to do this. I would just, at every line, just put a hashtag. Just every time you have a comment, you just want a hashtag at the beginning of that line. This will automatically put that hashtag for you. If you want to do it independently, you can. I've now lost the bottom of my. Uh-oh. Will be a good example to demonstrate how quickly the workflow is to get in and back up. So I lost that, but that's okay. I'm now going to show you something that I think will change your life completely. Go to New File and then go to R Markdown. You can call this anything you want. It might prompt you to install something, or it might just give it to you. Are you being prompted to install something? Cool. Let that start installing, and then I'll explain to you the powers that are going to change your life while that's happening. What an R Markdown file lets you do is it lets you create a document that has both your words and then code. I think it's confusing what they have there, so I'm going to delete everything there. But basically, this is just text, like I'm writing a paper. And then I can insert these code snippets, which I insert with Command Option I, but you could also just do the 3 ticks, or you can click here and go insert, and it'll insert a code snippet right here. So there's an insert. There's also a keyboard shortcut, Command Option I. And so what's really nice about this is I now can interweave a narrative with the data analysis. So just to do a really simple example,
so
yeah.
Our code goes between those three single quotes.
Yeah, 3 single quotes, the language that I'm writing code in, my code, and then 3 single quotes to end the block.
All right, it's a kind of a non-standard open and close syntax.
Very non-standard, yes.
All right.
And it is, yes. And I never think about that because I always just hit insert and then it gives me the 3 things. So I'm not typing them, but yeah, it's very odd.
And it certainly doesn't. It's not an HTML standard.
No, it's very different.
It's a markdown standard.
Okay.
So the triple backtick is a markdown standard for a multi-line code block.
Okay.
And the evolution of markdown has included now what language you use in the curly braces, so that if you have syntax highlighting in whatever you're using to convert your markdown to whatever else,
Right.
it knows what syntax highlighter to use.
Makes sense.
So it's a standard, just not one that's seen as often in the academic world at this point.
Right.
And so are you guys still installing? Or is it?
No,
It's
we're-
good?
we're
You're good. So have you created something like this? When you get there, this is when all the power happens, is if I click knit, it creates for me a document that is the combination of my text, the code, and then more text. And so people will create, like, dissertations are often written in this, where you write a bunch of text, you have code that executes, and it becomes all one large document, as opposed to you sort of copying and pasting the images that you've created in R into a Word doc, and then like when the code changes, you have to re-copy and paste, and you have these two live documents. This is a nice way to have everything all at once. So then I think will become more powerful as we go through, but you now have sort of two places that you can write R code in. You can just do it in an R script, whereas if you want to do human language, you do a comment, and then it assumes any non-comment is computer code. Or you have an R markdown document, which is the inverse. If I don't specify this is human language, and if I want to tell it that this is code, I need to use this 3 ticks insert code block thing. And so people will use either. It depends if you think you're going to be writing more human narrative stuff, then you're going to do the R markdown. If you think mostly you're going to be writing code and you're just going to have a few comments, then you would write the R script. It sort of depends it lets you shift your default. Does that more or less make sense? You don't have expressions like I've just changed your life, but I think it's one of those sort of slow, like it's slowly, the realization's really slow. Let's do, okay, now we're going to start playing with the Tidyverse. So Hadley Wickham, that second character responding to Jeremy Freeze's, sort of created or helped lead the creation of all of these packages. And the way I tell, so I had to install a package, which means it now exists on your computer. This library command tells it, hey, I'm going to use that package in R right now. And so you only need to install a package one time on your machine. But then every single time you want to use that package, you need to do this library command, which sort of pulls it up and gives you that functionality. Is that, And so you get these loading messages. The Tidyverse is a collection of packages. So essentially you've just loaded all of the packages that it's listed there. And Tidyverse collecting the packages is powerful because now I don't need to load each of these individually. All right, we got to introduce you to something else that's going to change your life. If I do 1 to 10, and I run that, it gives me a vector with the numbers 1 through 10.
Are you in the script or are you in the markdown?
I'm in the markdown right now. You could be following along in the script or in the markdown. I want you to continually to realize that I've changed your life, so I'm going to stay in the markdown.
I'll try to keep up with that.
All right. And so I create a vector 1 to 10, and then I'm going to take the mean of that vector. So it's literally going to add 1 plus 2 plus 3 plus 4 plus 5 up to 10 and divide by the number of digits as and it gives me the mean, which is 5.5. Let's say then, this is going to be sort of trivial and not make a ton of sense. But let's say I then want to take the median of that. It's an odd operation to do because the mean of 1 to 10 is 5.5, and the median of a number is just that number. So we would expect this to be 5.5, which it is. But I'm using this because I want to demonstrate like a key operator in R. So if you're going to read this code out loud, actually let's just do this because it's a fun instructional technique. Turn to someone next to you and each of you just figure out how you would read this code out loud to a person. So spend 15 seconds on that. Read that code out loud to someone.
Which would be just the mean, right?
There's no real trick. It's not like a booby trap or anything. It's like
The mean is just the number, right? So the median is just...
It's just a number of itself, yeah. I feel like someone over here had a good, like, how did you read that out loud? Someone give me a solution to that. The median of the mean of 1 to 10. So you sort of, okay, interesting. So the median of, and then I need to pause and think like what's going to go in there, and then the mean of, and then it's 1 to 10. And what I'm getting is you can sort of read it from the outside in or the inside out. Like I started with 1 to 10, I took the mean, and then I took the median, is one way to think about it. Or you can think, I'm taking the median, and you're like, of what? I'm not sure yet. Of the mean, of what? I'm not sure yet. And you sort of need to then collect in your working memory, like what's going to go in which place. So R has this operator which has sort of taken over the world called the pipe. And if you hit Command-Shift-M on a Mac or Control-Shift-M on a Windows machine, it should generate it for you. If you can't remember that shortcut, it is literally just a percentage sign greater than percentage sign. Is everyone able to produce that character on their computer? And so this operator says take the thing on the left and apply the function on the right. So if I run just this line of code, it took 1 to 10 and it applied the mean function. And if I then apply the median function, and so
1 to 10 apply mean. I got errors with that.
you got errors with that? I think it's a good time for pausing.
So,
Oh, cool.
So if you run that line and here we're doing this thing.
And the reason for that
And you
is that
actually can just run it just
it passes into one function at a time.
Mhm.
So it's
So yeah,
saying take all this value and put it in as a parameter to the mean function. So let's take the mean of whatever that is. And then whatever the result of all that is, let's pass that in to the median function. And then that returns whatever value.
Cool. All right, you control F zero, the bottom line executed. All right. Cool. Thank you.
Hit command enter.
Yeah, you must have some weird. I guess just highlight for now and you can type
So what are you doing? Because you have
We're gonna make sure everyone
it
can
was looking
sort of get this sort of
what
run.
can it pass to the next
Are you
line.
guys able to?
And so it was getting the syntax.
Okay, yes, that's happening.
So this.
So this is because you have within this code block with the triple backticks, that's saying
So
everything
I think
within this is code.
There's something worth
And
explaining.
then R doesn't know what the syntax is for that curly brace thing. So it thinks it's from the
Since what I failed to tell you guys is that, so when we moved over to R Markdown, sort of executing code becomes different. And so if I think my computer is doing this differently than your computer is. I'm guessing when you're executing code, you're getting it beneath your code snippet, whereas I'm getting it over here. Is that somewhat true for some of you? And also there's two ways to run this. I can either click this, which runs everything within this code block, or I can still run like line by line, like I was able to do in the script. Just to demonstrate, like I can just run that line, I can just run this line, or I can run them all at once. If you want it, so, oh no, I shouldn't have done this. We saw how this unfolded before. If you go to if you go to your preferences, so if you went to R Studio and then preferences, and then click R Markdown, see if what's the check mark that you guys have that I don't have? Is it the show output in line for all our markdown documents? It's this check mark that you have checked that's showing it in line in the document. And I don't have that checked, which means it's sending it over to the console when I execute. That's sort of a matter of personal preference.
I like the console.
You like it in the console.
So where? How did you get the preferences? Slow down in a second. So,
Yep.
got it. Thank you.
Oh, it's different for Windows. I didn't realize that.
You
So
find
yeah. All right. I want to get my console back.
What was the one click to run a single line of code?
Command Enter.
Command Enter.
Yeah.
Let's see if that. Let's make sure that works. Yeah.
Okay,
So that
sweet.
ran just that single line of code. The reason I don't have it checked is I want just like my code to be my code and my output to be my output. It's sort of alarming when I run something and all of a sudden all my code like goes somewhere else because some output's been generated next to it. Any other questions? I think this is a good point. Like I do not want people to get lost, so let's make sure that. I'm gonna have. Yeah, of course.
what's the difference between R and R Studio?
Great question. R Studio is, so you're running R in R Studio. R Studio is like software built on top of R that gives you this nice, pretty place to run it. R is like the engine underneath it. It's like we're using a nice car called R Studio, and R is the engine inside of it. You could, yeah, this one's like, yeah, it's the most. I think at some point there was competition, and then this is like an example of this, like Blu-ray versus like there's like high definition DVDs at some point. Like no longer are there high definition DVDs. Like Blu-ray just sort of won. But yeah, that's sort of the equivalent.
Another analogy to it is like R without the graphical user window overlay. It's kind of like, I don't know if you've ever tried to do Stata in Unix. In other words, you type in commands and it doesn't tell you anything, and then you have to sort of, you have to sort of run commands to see the output. You have to sort of like, you don't necessarily get any of the visual indicators of what's going on. So it's less oriented.
I think there's a way. Run R in terminal. We can maybe demonstrate this super quickly. What do you type? That's what I didn't know.
Yeah, just type R, capital R.
So if I'm in the terminal, I can just get the engine to run without all of this fanciness.
So R is a language, and then R Studio is an application so that you can edit code in that language.
So there will be people that run it like this. I don't think you would ever recommend it to a beginner. Like, you don't get all of the
It's very
benefits.
R is an offshoot of software that was developed, I think, by AT&T Labs in the early 1970s called S. S and S Plus, and it was free software. It's around the same time that they were developing Unix. I think probably it ran on Unix. And it was just a terminal interaction, like you could type in commands, but you type in command and you wouldn't get any feedback. And then you have to sort of find the object and list it, and it has an old days terminal interaction flavor. So I think R really started to become popular broadly when R Studio is the most recent of them. But there are several other sort of versions of the sort of graphical user overlay that give you a little bit of what we're used to with the Stata, which is sort of like you see the variables, you see the output, you see the commands. You get all those things together, and then it starts to make sense.
Other questions or concerns before we keep going? So I'm actually going to, I think R Markdown, I do still think it'll be good for you at some point. I'm going to work in an R script from now on because I think it'll avoid some of the complexity. If you want to continue to work in an R Markdown, you can. But I think if we avoid the R Markdown, it'll be good for now. So I want to make sure that everyone is able to load the Tidyverse. Great. Which you've already done. And so if you didn't have to exit like I did. And then you're also able to run just a command as simple as mean 1 to 10. And now you're also, what we were getting at, able to use the pipe operator to run the exact same command and get the exact same result. Is everyone able to do that? Is anyone running into problems? Okay. So, yeah.
My Tidyverse, it says some of the packages are built under our version of
I think, yeah, is it able to work?
it's like running all the rest of the commands. It just gives me the
I think that that's a little bit, I mean, part of the Wild West aspect of R, that a lot of different people contribute to it, and then RStudio is created independently of R, and it's sort of like the different, there's all sorts of different versions of things that kind of have to work together, and I had an older version of R on my home computer, and I installed this version of the RStudio, and then tried to install this version of the Tidyverse. It's like, well, but, you know, the version of this, and the, you know, I think there's occasionally going to be a head scratcher with that.
It's why the Python people saw it was like Homer in a really weird vehicle. That's like the depiction of that. So so if it's working now,
yeah, everything's working. Maybe
if the solution is to update everything at some point, which we can help you with there at some point. But if it's working now, let's. No. So, and this maybe doesn't look that this pipe operator doesn't look that useful in this small space. But as you stack multiple functions on top of each other, it sort of changes everything. I can read this as take 1 to 10 and then apply the mean and then do something else. Whereas if I keep stacking functions on top of this, I need to keep wrapping it. And now I have to do this sort of non-standard English reading of reading from inside out, which becomes unnatural.
Although, I mean, there is sort of math understanding of the order of operations when using the parentheses.
Is that, yes. Yeah. Like it maps super well to like f of 2 and g then applied to it, which would teach like 8th graders or something. Maybe we need to teach, maybe if I taught high school math again, maybe my students would be like writing this on standardized tests and either getting 5s or 1s depending on if the person had learned R. Let's start to work with a data set because that's, I think, where we're hoping to get to. So if you go back to this web browser, I've created a very, very basic data set. So if you go to the GitHub, so you can either click there or maybe you still have it open. Everyone's here-ish. tinyurl.com/ss382 will get you to this document. And then if you click on this GitHub link, you should get to this web page. Now, we're just going to download a really simple data set. So click into data raw. And this data set happens to be on hamsters, which I don't have any particular affinity towards, but it seemed like a nice toy example. Don't download anything yet, because downloading from GitHub is sort of confusing. Click into this. So now you can see the data set. It's very simple. There are 7 rows and 4 columns. Then, Scott, if you click on raw and then right click, is that the best way to do it? Okay. Click on raw, and you should get just this text. Everyone seems. And then if you right click, yep.
I mean, I can see. Yep, good. Got it.
There?
Yeah.
Now right click. And go to Save As. And then put this in the folder that we've been working in. So just find that folder and then save it there.
Almost separated CSV file.
And so now in that folder, everyone should have this hamsters.csv file, which we could open up with, I have Excel installed, so we could open it with Excel. We're going to sort of play around with it with R, but it's just your sort of most basic, incredibly small data set where we'll be able to see what we're doing. So I'm going to go back to RStudio. And now you should have a files pane. And since our project is inside this folder, now we're able to see that that data set's in there. Everyone's there. So the first thing that we're going to do is we're going to create this data set inside of R. So I'm going to create an object called hamsters. That object's going to equal, and now I need to tell R to like bring in this CSV to read it in.
Would it be better to use the
If to do this,
yeah.
it will do the exact same thing.
Okay.
Your code will look slightly more impressive if you use this. There's a keyboard shortcut for this, which is Option minus. And so that's what I'll use, but in case of confusion, I'll just use the equal sign for now. And then this is one of those things, we'll talk about how you figure out like what command to use, but take my word for it on this one. There's a function called read_CSV that we're going to find. And in read_CSV, I can show you how to, so like, let's just say you knew that read_CSV was the function, but you weren't like sure how to use it. If you put a question mark before the name of the function and then type it, and then run that line of code, the documentation will come up in the bottom right. And roughly 99% of the time when I open up documentation, I just go to the very bottom and see if I can find an example that's similar to mine. This documentation looks a little bit confusing for our purposes, but basically we're just going to give it the name of the file. So what's that?
We don't actually need a path because it already has that folder.
It's because we're in the folder. And so if I just do hamsters.csv, it knows to look in the folder because that's where my project's living and breathing. And then if I run this, it should work. Looks like we're having a...
You could see that it works by looking in environment and seeing hamsters down
It didn't work for me. Maybe I need equal sign here instead.
Let's make sure everyone's... Are you able to get it?
I see it there, but I got.
Awesome. It's not an error. It's
Okay.
telling you what it did.
Oh, okay.
It's messaging to you. It's confusing because it's a red looks way too scary.
My thing says hamster CSV not found. That sounds like an error.
there. Because people are getting
Yeah.
Okay, got
So
it.
you might be.
Yeah, I have an error.
Cool.
So he's going to hopefully address this. Where that should fix.
So what might be happening is
Oh, maybe I didn't have quotes.
it might be a working directory thing. If our project's not working and making your computer know where we are, you can set the working directory
Got it now.
by going to choose directory and then choosing the place.
I was lacking the quotes.
You were lacking a quote, okay.
Yeah.
And so on the like this quote around the hamsters.csv.
Yeah.
Okay, yeah. And those small little things like in this is why it
no,
becomes
I mean,
scary.
Anytime you're learning a new language, that's the syntax that really makes you cry.
Yeah, is the quote.
Like the double equal sign in Stata. It's like, since when is the single equal not good enough? Since you need the double equal. Many tears have been shed about that.
And so when you read it in, it should have given you messaging, which tells you, okay, there's 4 columns in this data set. The first column, it read it in as a character, which means it was just words. The second column was a character. The third and the fourth column were both numeric. Double is a way of saying numeric. And this makes sense if I look at this. The first two columns are characters or text or strings. The third and the fourth columns are numbers. And so if you just type hamsters and run that, it just shows you. Or alternatively, in your environment, you can click this play sign next to hamsters, and it like pops up with some information about it.
Mm-hmm.
That's one way. Or if you have this data set printed fine to my screen so I can see what's going on over here. But if you had a bigger data set, you could scroll through it by using R's version of the browse command view. So capital V, I, E, W, and then parentheses with hamsters in between it. You cannot edit the data that way. And I think that's a good thing. You do get some additional functionality. For example, I can arrange or sort my data based on different things. I can filter if I click here, so I could just look at people named Amy. So you get just a little bit more of functionality that allows me to peer into my data set. I've chosen this data set for educational purposes just because it's so constrained that you can always see what's happening. Of course, usually you'd be working with much larger data sets, but then it becomes a little more difficult to figure out what's happening. Cool. So now we have in R an object called hamsters, which is a data frame or a data set or whatever word you want to call it. And it has 6 rows and 4 columns. And now the question becomes like, there's things we'll want to do with this. Yeah, you have a question with that?
So, we're saving, let's say, the script, and the data set has already been saved.
Yep.
What are the other things that are ending up in this R workspace that we could access later? So, for instance, if we run a model, you have to pipe that to some new name, and that creates an object.
Yep.
We'll pull that later. But if we just make a table, if we just want to sort of like view it, the console is lost once we close down, right?
Correct.
So does that mean that the evidence of that table, we have to recreate it later, or is it printed in one of these? Is it saved somewhere?
So if you were creating a table, I think there's 2 things you can save. You can either save the code that generates that, right, and then just rerun that code.
Right.
Or, and this is where the R Markdown files are useful, or I can write the R Markdown file and then execute the R Markdown file. It can create a Word document or a PDF document or an HTML document, and then I can save that file. And the R Markdown's nice because now I have the code, the R Markdown file, and I have what is essentially what the console looks like, which is now saved as a PDF or something like that. Other questions or thoughts before we keep going? So now that we have a data frame, I think there's like maybe 5 basic things that you would want to do with it. Can anyone guess what those things are? In Stata, what are the basic things? What are the basic operations that you might do with a data set?
You do a sum command in Stata to sum the distribution of basic statistical things you want to know.
So you could summarize like each variable or something. Tell me the mean of each variable. Tell me the min and the max of each variable. That's one thing. Stata also has like a gen command, which creates a new column.
Right.
So I think that's a basic operation. There's also like, what do you call it in Stata when you remove some rows? Let's say I only want to keep Amy. That would be drop.
Yeah.
So that's like filtering some rows.
Yeah.
I can also drop columns. So gen adds a column. I could remove a column. Let's say I no longer care if they live in a rural or an urban area, right? Trying to think what else you might do. How do you arrange your data? Like let's say I want to sort. So I think there's like four, like you can summarize, you can add a column, drop a column, filter out, and arrange. I think you can just do like amazing things with those 6 commands or something. So I want to give you that power in R. Let's start by filtering. Let's say I just care about Amy, and in this data set I have 2 Amy's. One lives in a rural location, the other lives in an urban location. One has 7 hamsters, one has 3 hamsters, and oddly, it's a lot, and it's also weird that Amy in the urban location with fewer hamsters has more hamster cages than Amy in the rural location. Like she should give the other Amy a cage at the very least.
7 hamsters, 1 cage. That's trouble.
Have you had this experience?
But I just have a feeling they're eating each other before too long. You know.
So let's just look at Amy. So it seems like we're really interested in Amy and the hamsters. So the command I'm going to type is filter. That's the command that gets rid of rows. And the first argument that I give to filter, so filter is a function, is I always have to tell it the data set I'm working on. And then comma. So filter is a function, and I'm going to give it a few things. What do I need to tell filter? Like what in human language, what am I trying to communicate? What am I trying to do right now? Right? Like I need to tell it a condition, which rows to keep. And so this is name equals Amy. And so you're exactly right. I'm going to give it the column that I am using. And then some conditional statement. In R, it's a double equal sign. And it's double equals because equals makes assignment, double equals compares. And then quotes, because Amy is a string here. It's like a name. And if I run that,
So have we lost those other people from hamsters, or
so the hamsters object is not altered here.
okay?
You have not, all you've done is you've said filter this object and then print out the result, but I haven't saved the results of this. So when I run a command and don't assign it to an object, it gets, like I just did it, but nothing
Okay.
gets saved. Your question actually suggests the next thing that we should do, which is like,
what is that comment on top between your command and the output? A Tibble. I understand that 2 by 4.
Uh-huh.
We have 2 rows and 4 columns. But who's Tibble?
so Tibble is so base R before Hadley comes and saves the day, has this idea of data frames.
Yeah.
And so earlier we were talking about empty cars,
Yeah.
and it comes with R and it's a data frame. Notice how when I execute empty cars, how it prints.
Yeah.
It's atrocious. Like it just takes me to the bottom. I don't see my column headers. It's wrapped in a weird way. It doesn't tell me if these are numbers or strings.
Yeah.
Hadley looks at this and says, this is garbage, or maybe this is a good start that I can build off of to be a little bit more diplomatic. And he says, let's instead of having this data frame thing, let's have what I'm going to call a tibble. You can sort of think as a table, which is a new type of data frame that has nice functionality, like it tells you that there's 2 rows and 4 columns, and it prints only the first few observations, so you don't get sent shooting down to the bottom of your screen. Does that make sense?
So they're both tabular data structures.
Right.
In some sense, they're the same tabular data structure in a lot of ways. But the Tibble is the Tidyverse version that has specific methods and functions and what Hadley Wickham considers to be improvements. But a lot of our people will still sometimes go back and forth. There's some performance gains on really large data, on some specific operations using data.frame. But most people can just use the Tibbles and Tidyverse, and that's all you need.
So we didn't create, when we ran this command, we didn't create any new objects. We just ran the command, and it didn't, instead of
Put
a,
it to display.
it just displayed the results.
Right.
Let's now, instead of just displaying the results, let's assign this. I'm going to create a new object, which is the result of this function, and I'm calling it hamsters only Amy. And now if I run that command, nothing prints, but instead I get this new data frame. And now inside of that data frame is only Amy.
Right. So in the files, it doesn't show up in my files right away, but it shows up in the environment.
Correct, because the file is like the folder.
Right.
So it's not like I've written like a new CSV or anything.
Okay.
I've just made an object in my R environment.
Okay, so it's in the workspace, that .r project has the Amy, the hamsters with only Amy.
Correct.
Okay.
And I could turn that into a CSV or something. We haven't. So
I mean, that's one of the questions I have about R and the R workspaces is keeping track of what all this stuff in there, because one of the things, this is sort of for the broader class, is like in the little Stata world, you have the log, you have the data set, you have the log and data set. Maybe that's it, and the do file, right? So those things are all quite small. And I mean, well, the data set is what it is, but it's not growing unless you're adding variables to it. But the workspace, every time you run a model, and this is true, for instance, if you took that big CPS 2000 data set, you ran 20 models, all of the output and matrices from those 20 models would then be stored in the workspace. The workspace would grow quite a lot. So the workspace is like a tent with a whole variety of things in it. And as a new R user, I get a little bit confused about what the heck is all in the workspace.
So what's in the workspace, this is showing you what's in the workspace right here.
Mm-hmm.
So it's anytime I create an object and give it something, that gets saved in my workspace. There's now, usually it's not recommended to save your workspace every time you leave R. That happens by default. Instead, what's recommended is to always start with a new workspace and then execute the code that gets you to the place that you want to be. And you have a look on your face like that's a controversial or...
Well, it's like, I can see the logic of that, right?
Uh-huh.
In other words, that way you're not carrying around on your back 1,000 objects that you don't need, taking up space all the time. But then you might want a couple, it's like depending on how the project is working, you might want a couple of those objects again. And you might or might not have exactly the commands in your script to create it in the order that you created it in. So, I mean, that part is a little, it's a little confusing to me. I'm sure if I used R more, I would get used to it better. But I, my mind reels a little bit with what all is in it. Like I've done some R sessions where I took the data sets that I knew and ran a bunch of models, and then that R workspace got quite enormous because every model is kind of replicating the data set and the output. And then so like the data set is 10 meg, but our workspace is 200 meg.
Right.
And so, but that's just because I'm an R novice. So I see what you're saying about, the script is obviously the super compact version of things. But if you've been doing a project for a month, it's not always obvious to you where in your script is the right set of commands to get you the right answer from the right version of the data set. Because maybe you created new variables, maybe you ran that model before you renamed that variable. I mean, there's a whole bunch of things that go along. So it's, it would take a little.
It's like a workflow question. So like the solution I use when I'm working in R in my research is I'll have one script where I'm being messy and I'm doing a bunch of stuff, but then I'll be like, oh, in the future, I'm definitely going to want to both read in hamsters and hamsters only Amy.
Right.
So I'll create a new script that's just sort of the key
winners.
components to get to where I want to be.
Fair enough.
And I think your solution is, well, I got there. I now have the object. Let me just access that object. I'm
Right.
saving the code to get there. It's sort of.
So each time you're then, each time you come back in,
Yeah. So like, I'm not gonna don't follow along and do this, but I'll just demonstrate it. So like right now, I'm in R. Let's say I'm done for the day. I quit out. Now I come back and got my coffee and I want to get back to work. My workflow is I open up this R project file. It gets me there, but you notice my workspace is totally empty. I have nothing in there, so I'm sort of brand new again. And then I'll go to what I called main here, and I will just highlight all of it and run it all. And now I'm back to the spot that I was before I left.
There are things that you need to carry over to the next section. Then you typically save them in some way. So I very often see projects organized as you have one R script, which is loading the data and cleaning the data. And that's one file. And maybe at the end of cleaning the data, you save a new CSV file, which is your clean data file. And then you have a new R script, which is your analysis file, or like some particular type of analysis. And you don't load the original data, you load the new CSV data script. You could go back and rerun that entire cleaning step. All the code's there. If you want to go back through it, you need to revise it. You just rerun the code, modify it as needed. But sort of save incremental things that you need to carry over to different parts so that you don't rerun. You don't need to rerun the cleaning every single time you want to do an analysis.
What about the R data set? Wouldn't you want to save the data in R data rather than CSV? I mean, the R data would allow you to keep labels and all sorts of other things that the CSV wouldn't allow, right? So R data would be the data format if you're working in R. You'd want to keep everything in, right?
I think that depends on the type of data you have. So
Okay.
I work almost entirely with textual analysis.
Okay.
I never have a need to do R data. I only ever save things in CSVs or JSON files because I move between R and Python a lot, so I need interchangeable
Right.
formats. And the type of data that I work with I don't get an advantage from R data. But maybe Ben could talk about when you would use R data files versus CSVs.
So the R data file that you're talking
Yeah.
about, that actually saves your entire workspace.
Okay.
And so for that reason, some people will recommend you don't ever use them because
Huh.
you want to be saving specific objects one at a time.
Right.
So if I think that's like a save command. I could generate an R data file that has everything that's in my workspace. The other thing is a .rds file, which will save one R object. And this gets to your question of like, I have a tibble right now. If I want to save a tibble, the only way to save a tibble is with an RDS file. Because like a CSV, it's going to take away all of these sort of little perks that we have.
Yeah.
So that's one thing I'm saving. That the other thing, and I know I'm going to have to exit and start again.
So just to get back to R data, and how is the R data different from the .rproj?
The .rproj is just a file that opens up R in the directory it exists in. So .rproj does not contain any data or anything. It's just like a access point to R in a specific folder, which is a nice workflow addition. If you go to your preferences and go to general, so I think this for Windows was under tools and then for Mac was here, there's the workspace preferences is where we're making decisions about these things. So save workspace to R data, I have as never. You might have it as something, which means if you said always, every time you leave R, the last thing it's going to do is it's going to take everything in the workspace and it's going to put it in an R data
Right.
file. For my workflow, I don't do that. Like, it's an option. You certainly could do it, despite it being slightly frowned upon. And then, so this is at close, at exit. At startup, if I click this, when I open the R project, the first thing it'll do is it'll look for a .r data file in my folder, and if one exists, it'll load all of that stuff into the directory. So I do neither of these things because I want to just start with new workspace each time, but you could do both of these things, and then you would both save your objects and load them each time. Yeah.
So I would have this up. I saved it at history. You can save a history, but not save a .r data file.
Yep.
So then how would you access that history? And what does that history look like? What is it saving?
So it is saving all of the commands that you executed. So right now, if I type something into the console directly, that's not in any script, but it would show up in this history file. What's that?
Like a lot.
It's like a log.
Awesome. And so what kind of file format would that be in?
It's like dot. We can do it and see what happens. I have to exit R to.
So Ben is teaching sort of what are coming to be known as sort of best practices within the R and data analysis community. At the end of the day, you need to adopt a workflow that works for your particular way of doing things. And so if you're someone who really wants to maintain all the stuff every time, go with the R data. In a lot of ways, there's nothing wrong with it. It's really sort of we're going to try to give you what we think might be the best way of doing things, but then you ultimately need to adapt it to the way that actually helps you get your work done in an efficient, successful manner.
So I'll get back to where I think you probably are, which is two objects. One is my full hamsters, and one is after having filtered Amy. You have a question or something?
No.
Good. Good. Okay, so we have what, 6 minutes left?
Yeah.
Awesome. This is really fun. I love teaching this stuff. So
I guess it's really helpful. It's tremendous. The first few times I sat down with R, I just found it hard to navigate.
yeah,
So the navigation is just really helpful.
awesome. Let's do one. So let's now take hamsters only Amy, which is 2 rows and 4 columns.
Yeah.
And let's do what I think is the other simplest thing you would do. Let's drop one of the columns. And so in order to do that, anytime you're working with columns, the function is select. And so think of filter as operating on rows and select as operating on columns. And every time I use one of these functions, the first thing I give it is the data set to work on. I'm going to work on the hamsters only Amy, but I could have chosen hamsters. And then what I'm going to do is, let's say I don't care about the hamster cages. So perhaps the simplest way to do, if I want to drop a column, I'll just put a minus sign. And then I'll type the column name that I want to get rid of. What problem are you running into? Scott, do you want to check it out? Did you not save it? You could also just use hamsters, I think, if you didn't.
I have it in my environment. Is that not good enough?
You guys didn't put it.
Oh yeah, there we go. Take the misspelling. Thank you.
Another error?
Yeah, my spelling is bad. I'll have it done.
So we just dropped it, but like, let's say we stakeholders.
So I've like if you read this, like I created a hamsters object. So now I have this hamsters. I have like the full data set here. Then this second line created another object, which was only Amy. And so I have the full data set. I have the ones with just Amy. And this line nothing happened here except for it printed the result here.
Okay, so it didn't actually modify your modifier.
It does not alter the thing unless I could assign it back to the same thing. The only way it would modify it is if I like tell it, take the results of this and put it in the object.
Right. Kind of like for variables and say like replace. You drop the variables, it's gone.
So I could say this like hamsters, let's just shorthand underscore Amy underscore no cages. I could create that object, and now I'll have a third version of this data set. Yeah. Ask.
So let's say you end up having like, I don't know, like 130 different or 1,000 different objects. I don't know if we're going to do that, right? It's the only way that you know what you have in terms of the objects in your
Uh-huh.
is this kind here with this data.
Yep. And there's ways you could like, there's a function that like lists all of your objects, but yes, it is something like that. And so you could see how you could sort of proceed like this. You could read something in, you can do something to it, you can do something else to that. I'll close by showing you how like the pipe makes all of these happen together. So the way I would write this with that pipe is I would say, I'm going to start with hamsters. That's going to be my first thing. And then Command Shift M or Control Shift M should get you % greater sign %. And now I'm going to hit Enter. I don't need to, but it's just sort of good style. And I'm going to say, all right, I want to filter. And this is, let's do the same thing as we did before. Bless you.
Because we're starting with hamsters, the filter command doesn't need to specify the data set.
Because I've used this pipe operator.
Okay.
This pipe operator says use the thing before. And so line 10 on my screen and 12 and 13 are synonymous. They do the exact same thing. So if I run this, now I get just Amy. Now what the pipe command lets me do is now I can take this and I can do this process again. And so the next thing I did was I'm taking the result of this. We did this before by making a new object. And I'm going to do select. And I don't need to tell it what data frame to use because it's going to use the thing that comes from before. This is the like 1 to 10 goes into mean and the result of 1 to 10 into mean goes into median. And now I'm going to do like minus hamster, what's it called? Hamster cages. And so
use the pipe operator, it takes whatever you've got that you're piping in and passes it as the first parameter to the next function.
And so where we'll pick up next time to have a happy close is like this. I think this is really readable as you keep going. So I started with hamsters. I filtered to only Amy, and then I took away the hamster cages column. If I were to write this in the old format, I would have to take hamsters, apply this filter, and then either save an intermediate object, or I can do this And I just think this is much more readable than this, though they both do the exact same thing.
I must be really old fashioned. I'm used to that.
Like this is, you're good with this.
Yeah, I'm good with that, but I have it many times in my life come to that, like, you know, you have 17 open paren and 17 closed paren, and there's a little bit of misidentification of the order of things.
Uh-huh.
So yeah, I see what you're saying about that first thing. It's easier to parse.
Yep. And we can, I think it gets easier as you add in like additional things.
Makes sense?
So we're already 2 minutes over. That seems like a fairly okay stopping place.
Super great. I really appreciate this. I really appreciate this. I feel like this is a great. I'm learning a lot. So yeah. Thank you. Ben.
You are very welcome. It's fun to be here.
So same time.
Same time in 2 days.
Thursday. Awesome.
See you then and there.
Thank you.